Hey everybody, this is Mrs. Slauson, and so we are going to be going over a follow-up capstone practice. This is similar to the ones that we have already done in class, so that's another good place that you can look at, but otherwise let's get started. So I'll be showing you a couple of different ways that you can solve these problems. Most of them you can pretty much use your graphing calculator, and remember, Desmos is an option when you take this assessment. So let's just start with our first question. So how would you describe the following polynomial? And so basically what you need to know, are there n behaviors? So for me, in my class, we talked about this highest exponent, so actually just the entire leading term, and that it will tell us the shape. So because we have an even power, I know that my n behaviors, it's going to look like some type of u. So maybe your teacher just kind of showed you the n behaviors, and what I did in my class is we just kind of drew a quick u. The next thing you want to realize is that this negative in front says this shape is going to flip. So when we're done, if you're just focusing on the n behaviors, it would look like that. If you kind of want to draw a whole picture to it, it would look like this. And so what's happening on the left is it's falling on the left side and it's falling on the right side. And so it's falling to the left and falls to the right, then I would be selecting option D. Now, if you didn't remember this, you do have the option of going to the y equals button on your calculator, typing it in, and going from there. So let me brighten this up a little bit. So you could just type it in, and you could do this on Desmos as well. And I always like just to start it with the zoom 6, and so watch it graph. So if you notice, it's kind of the same idea. It's falling on the left side and it's falling on the right side. So I can use my technology to get the shape of this as well. On the next one, given that 2 plus 3i and 3 minus 4i, what we want to do is find the product. So product means it's the answer to a multiplication problem. So we're just going to multiply these two sets of parentheses. And so this is what, it's just the distributive property. In my class, we call it the neighbors meeting the neighbors. So when I start, I get 6, and when 2 distributes to this, I get minus 8i. And then I'll have the 3i distribute, and that's going to give me a 9i, which I'm going to stack with its like term, and when I distribute to this, I get a minus 12i squared. So from there, I'm just going to simplify this up. And the idea is we want this to be a plus bi, so a real number plus an imaginary number. And the problem is this term here isn't quite fitting the bill, and so that's where this comes in handy. So the square root is worth -1, or sorry, the square root of -1 is worth I. If you squared this left side, that would turn this into -1, which means I would also have to square this side. And so as it turns out, I squared is worth -1. So I could go to this term here and just replace the I squared with -1, and then that term turns into 12. So it starts to look like this, and then I can combine the real numbers and be done and have 18 plus 1i. Now technically this is a multiple choice question, so you would see this listed, but when you see it, they would not put the 1 in front of the I, they would just have this. Now, if you're watching from another class, there is an option for the graphing calculator. What you need to do, this would not work on Desmos though, you press mode, and if you scroll down, you will eventually see a line that says real a plus bi, and then this part over here. What you want to do is get to that row and go to a plus bi, so that it's highlighted. So right now you're going to notice I've just highlighted real. I want the a plus bi. And then you could actually just type this into your calculator like this. Your I button is down here above your decimal. So you could just type it in exactly as you see it. So parentheses 2 plus 3i, close those parentheses, 3 minus 4i, and there's the answer that we had. So quick little cheating trick on the calculator. All right, number 3, we're going to find the remaining zeros of the following function if one of the zeros is x equals 1. So the idea of finding the zeros just means we've set the problem equal to 0, and we need to solve for x. But when there's more than one type of x, when x has different degrees with it, you need to try to factor it. And if you did try to factor it, I would try a GCF first, which doesn't exist, and then I would do the grouping method. So I can factor an x squared out of here and have x plus 1. And as I tell my class, when we do the GCF here, I need an x plus 1. And so I would try to factor out a -5 for this, because when I distribute it back in, I want the -5x. But also when I distribute it back in, I want 3, and I don't. I get -5. So as it turns out, this isn't factorable, which is why you're getting this clue over here. What you can use is that synthetic division and put these coefficients inside the box, and then you just start. So you drop the first number down, and then you multiply, add them up, multiply, add them up, multiply, add them up. And remember, this says it worked. We want 0. This is saying if I put 1 in here and did all the math, I would get 0 as an answer. And then we can take this part, leave this as a constant, give an x to this and an x squared to this, and then factor it. So if I factor it, I'm just looking for factors of -3x squared that get me to this 2x, and that would be a 1x and a 3x, with the 1 being negative, because when I multiply these, I'll get this term on top. When I add them, I'll get the term on the bottom. And then I can go to my parentheses of my factors, and the first thing I focus on is, this x squared. I need a term here and a term here that when they multiply or distribute to one another, meet each other, I get x squared, which would leave me with an x and an x. And then I'm going to focus on these side numbers. And can I take x and multiply it to something and make -1x, and that would be a -1. And then could I take x times something and get the 3x, and that would be a +3. And then once you have your factors, if you just set your factors equal to 0 and solve, you'll see that one of the other zeros is -3. And when you set this one equal to 0 and add 1 for solving, you'll see that the other one is 1. Now your other option is to go into Desmos, enter this into your calculator. So this just takes a moment. And again, every time I graph, I always start with zoom 6 on the graphing calculator. You can put this in Desmos as well. And we want to find the other zeros. And what you're going to see is that the other zeros, besides 1, is we have an additional 1 and a -3. And I could see that here. And this is probably a multiple choice question. I just didn't make it there. And remember, because this is a bounce, that meant that 1 as a 0 showed up twice. All right, so all of the zeros are, besides the one that they gave me, is the other one that we found, and then the -3 that we solved for. But I could see that in the picture. -3 is crossing, so it showed up once, and 1 is bouncing, so it showed up twice. All right, number 4. So which of the following statements is false about the graphed equation or function? So here's the picture, here's the function, and here's the graph that goes with it. And so which of the following is false? So without the calculator, I would just run through and check these out. So the y-intercept is 0, 8. So all y-intercepts have an x value of 0. So this is for checking A. If I did just put 0 in for x and then follow my order of operations, will I get 8? So the 3 is just going to drop. These parentheses turn into 2, and then here I'll get a -1, but then I'll square the -1 for a 1, and when I multiply, don't add these, I get 6. So actually right away I see that my y-intercept is 0, 6, not 0, 8. So the correct answer is A. Let's just check these others out. It is falling on the left and rising on the right. It has one relative maximum. Maximum, again, is that high turning point. So this is a relative max. It's the one high turning point. This one is a relative min because it's a low turning point. And the function has a 0 at -2, 0. Well, that's right here. Now, if you aren't great at finding the y-intercept, which you'll need to be when you take the retake of chapter 4, the other option, because this doesn't show up very well, is you could go to your y equals, type in your equation, and then just go to the table and look for when x is 0, and you're going to see that your y is 6. So for Capstone, the calculator is a great option. On the retake, it's not a good option because you wouldn't be able to use your calculator for something like this. All right, that's question 4. Let's take a look at the next one. So this is not numbered, but we'll call this question 5. So we're going to solve for x. So ideally, when you solve for x, you want it in factored form. So this is as factored as it gets. So this one I can go ahead, set that factor equal to 0, subtract 2, and there's one of my x. There's one of the solutions for x. The other one, I would try to factor this first. So I need factors of 10 that get me to 4. And the only factors of 10, 1 and 10 will never get me to 4, and neither will 2 and 5. So as it turns out, this is not factorable, which means you will need to know the quadratic formula because that's your backup plan when it's not factorable. So here's the quadratic formula. X equals opposite b plus or minus. You make a square root. B squared minus 4a and c. All of this is over 2a. And from there, I can identify that a is 1, b is 4, and c is 10. So finding the other answers or values that if I put them in for x, completed my math, would give me 0. So x equals opposite of b plus or minus. I'm going to make a big square root. I'm going to go ahead and take b and just square it. So 4 squared, 4 times 4, minus 4 times my a and c, and then all of this will be over 2 times a. From there, where I want to bring my focus is inside my radical and get to this first. Now, you would have a calculator, and you could just type in 16 minus 4 times 1 times 10, whether it's on your graphing calculator or on Desmos. But what your graphing calculator is going to do is do the multiplying first, which is 40, and then follow with subtraction because multiplying happens before subtraction. And when you subtract, you get the square root of negative 24. So this will be a multiple choice question, and you will not see this in your options. So the first thing I want you to realize is that when we take the square root of this negative number is that you will get an I. So let's start there. I'm just going to put a little I over here. And the next thing I want to check out is 24 is not a perfect square. So what I'll do is find its factors that are. And so here are the factors of 24. And I want the biggest factor that is also a perfect square or has a perfect square root. So that's going to be the 4, a 4 and 6. So then I could break it into the square root of 4 and the square root of 6. There's the I. This could become a 2, and there's the square root of 6. And I'm not going to write it quite like that. I'll write it a little bit differently. So moving on, I'll write it a little bit lower. So here's the negative 4, plus or minus. The 2 goes first, then the I, then the square root of 6 with this 2 here. And this is a great answer, but this is still not what you're going to see in a multiple choice. You need to look at that factoring triangle where you take the coefficients and the constants, not the square root of 6, and you look what can you divide all of those by, and that's a 2. And so if I divide this by 2, I get negative 2. Divide this by 2, and it's a 1, which they wouldn't write the 1. They'll just leave as I root 6. And if you divide this by 2, that's a 1, but they don't usually show a 1 in a denominator, so this would be your final answer. So you do have to know your quadratic formula, and you do have to be able to simplify the radical as far as you can. All right, let's go to the one next to it. So which of the following functions is equivalent to f of x? So if you decide to take the chapter 4 retake, one of the questions will say, given the zeros, write an equation and get it into standard form. So where you will start is getting it into factored form, which this is, and then you will have to multiply your factors to get it into standard form. And so this is what I nicknamed the neighbors meet the neighbors. Here's 1, 2, and 3. And when a group of people meet, we're only going to have 2 meet at once. So we're just going to have these neighbors meet, or focus on the distributive property for those 2 factors and leave this one out that I'm covering. So I'm going to start and get x squared minus 3x, and then 2x minus 6, which I like to stack my like terms, and that gives me x squared minus 1x if you want to put the 1, minus 6. And now you've multiplied those two. For this, you'll take this and multiply it by the other factor. And so again, I call it the neighbors meet the neighbors because x squared is going to come over, and I get 2x cubed, plus x squared. And if you want to put the 1 there, I will for now. And then this will distribute over and give me minus 2x squared, which I'll stack with its like term. And then I'll get a minus 1x, so scribble that out. And then the last set will meet, and negative 6 will go over. For negative 12x, I'll stack it with its like term, and then multiply those and get negative 6. And again, the reason why I just like those like terms is because, well, I can just drop that down. I can add these up, add those up, and 6. And so hopefully we're seeing it unless I made a mistake. So I'm going to pause here real quick and see if I made a mistake or if just the answer choices are incorrect. So time out. All right, so there is not a mistake in my work. The problem is there's just not the answer choice showing up. So when this is handed out, I will change one of these. What's the one that probably is the closest is I'll probably be making it B and changing this into minus 13x and minus 6. So just a heads up on that. Sorry about that. Again, I double checked the math. I don't think I missed anything, but it is always possible. All right, let's go to the next one. Which of the following is not a factor of the function? So the idea is if this is in standard form, what I really want to do is get it into factored form. So the first step of all factoring is to try GCF, which isn't happening. So I will move into my grouping method. And from my first set, I will factor out a GCF of x squared and be left with x plus 3. And when I do my GCF here, I will need my matching parentheses of x plus 3. And so what would I factor out of negative 4x to make x is a negative 4? And then I would just double check that it works. So if I distribute this back in, I make this term. And if I distribute this back in, I'll get the minus 12. And then one set of factors is x squared minus 4. And the other set is the x plus 3. So if you notice, x plus 3, that is a factor. So can cross that one off. But I'm still not seeing anything because this is not quite this. And as it turns out, you do have to factor it completely into a differences squared of x plus 2, x minus 2. And I'll just drop down that x plus 3. So these are all factors. So I can eliminate A and B, and D is not a factor. So don't forget about a difference of squares. And if you just don't remember what that is, you take the square root of x squared, which is x. You take the square root of 4, which is 2. They become the terms in your factor, and then you have a plus and you have a minus. And you can put the minus and the plus, it doesn't matter. So for this one, we're going to write a polynomial in its factored form. So when we did this in class and on the short answer part, you had to decide if A was, you actually had to solve for A. Here, you're not going to solve for A. Actually, you're just going to put it in factored form and then pay attention, should there be a negative hanging out in front. So it's going to be a very basic one, and you would see this as a multiple choice, but I'm not going to make it that easy on you. So I have a 0 at negative 2 and it's crossing. I have a 0 at negative 1 and it's crossing, and I have a 0 at 1 and that's a wiggle. So when I start to write the factors for this one, I would write x plus 2, leave it as an invisible first power because that's what a cross is. I would write this one as x plus 1, and I would write this one as x minus 1, but since there's a wiggle, I want to put the lowest exponent that I can that will give a wiggle, which is a third power. Now, if you notice, it's rising on the left and falling on the right, like this, which kind of looks like, although there are more bumps to it, a line, a downhill line. So what that means is there is a negative or even a negative 1 that caused that to happen. Okay? So the main thing is get the factors, assign the correct exponent, and then just see, should you leave this positive or should there be a negative in front of it? And again, because of the end behaviors, I need to make it negative. All right, 2 more to go. So which of the following statements is false about the function? And yeah, okay. So which of the following statements is false about the function? So here we go, and I can graph it. I'm not going to graph it the first time, but the functions have an x-intercept at 0, 0, 0, -2, and 0, -4. So, and I realize these are all typed wrong. Should be 0, 0, -2, 0, and -4, 0. So that's not what that was meant to be. All right, but you will all have the corrected version when you look at this. So anyway, going for this, let's see what the zeros are. Those are our x-intercepts. So you set each factor equal to 0, and then you solve. So divide by 3 here, and you get 0. Set this one equal to 0, and subtract 2, and that's a -2. Set this one equal to 0, add 4, and as it turns out, let's see. Well, again, I don't know if this is a typo. Let's investigate all of these. This was some fast work by Mrs. Slauson when she put this together. The graph rises to the left and rises to the right. So let me switch colors on you here. Rises to the left and rises to the right, which, you know, you can have some bumps in here along the way. So based on if this were in standard form, this is a 3, so I'm liking this so far because this indicates a positive behavior. And then if I looked at how many x's I have 1, 2, 3, and 4 more x's. So here's 1, there's 2, 3 because of that, and there's the 4th x. So if this were in standard form, this would be my leading term. So that makes sense. Yes, I like B, so that is not false. That is true. The graph has a y-intercept at 0, 0. So again, that would just be putting 0 in for all of these x's and seeing what I get. So 3 times 0, 0 plus 2 squared, 0 minus 4. So I'll multiply those. That's 0. That's 2, and then 2 squared is 4. And then I'll 0 minus 4 is -4. And again, I'm going to multiply these. Don't add them. And 0 times anything else will give me 0. So my y-intercept is 0, 0. So that is not false. That is true. And it has a bounce at -2. So at -2, that is one of our zeros according to this, and it will bounce because that -2, because of that squared, is technically showing up twice. So since our solution has a multiplicity of 2, which means it's showing up twice, this would give it a bounce. So either way, A is wrong just for the way they typed it. And if it were correct and it says -4, 0, it's actually 4, 0. So A is our false one. And sorry, these graphs did not turn out very well. Hopefully you have a better printer than I do. Which of the following is the graph of this? And so what I'm going to do is actually, you can just type this into your graphing calculator. And you could see which picture matches it. That is probably the easiest thing to do, so just zoom 6. And if I'm looking, you know, this is just a little more zoomed in. If you notice the scale, again, you probably can't because this is very small, but this is actually going by halves. And this is also going by halves, where this is going by 1. So when I look at which one it probably looks like the most, it does look like B. Now, how could I do this without the graphing calculator? I could see that I should have a 0 at 0, at -2, and at -1. This has a multiplicity of 3, so this would be a wiggle. This would be a bounce since it's a multiplicity of 2, and this would just be my cross since it only shows up once. So when I start to look at options, you know, here is the -1. That's a wiggle. Here's -2, which is a bounce. And here's 0, which is a cross. The other thing is the negative. If I looked at the leading term, it would be a negative, and then or a -2, and then I have 1, and then 2 more x's here, so that's a total of 3 x's, 3 more x's, which gives me a total of 6. And so I know my end behavior should be like this with some curves. And so again, that's why this is showing up as my best answer. Just going back to the last question, you could have also put this into your graphing calculator and then just verified all of these things through a visual picture. So that's it. I hope that helped. Sorry for the typos.